Right. VLSM is one of the topic that we have pending. VLSM. Variable length subnet mask. You see, we know what is subnet mask. We know what is length of the subnet mask. For example, class A length is /8. Class B length is /16. Class C length is /24. And if you do some subnetting, then you may have like /30, /10. Some intermediate number also may come. It depends on the subnetting. Now we understood what is subnet mask. We understood length of the subnet mask. Now what is this new topic called variable length subnet mask? Variable length subnet mask. Let's see what it is. This looks like a variable length subnet mask. You see, /8, /16, /24, /30. Of course, this is variable length subnet mask. But I cannot call this as variable length subnet mask. The reason is I said class A, class B, which means these subnet mask lengths are not of same network. This is the length of class A network. This is the length of class B network. This is the length of class C's network. So I cannot call this as a variable length subnet mask. But if I'll have a single network and subnetting like this, then I call it as variable length subnet mask. 10.0.0.0/16, 10.0.0.0/24. You see, it's the same network. 10.0.0.0/30, 10.0.0.0/20. So the length of the mask is not the same for the network 10. This we call it as variable length subnet mask. Now, just to understand the term variable length subnet mask, I spent this couple of minutes. Now let us go to the actual variable length subnet mask. And also we should know the opposite of variable is fixed. So far, the subnetting that you did is a fixed length subnet mask. For example, I used to say 10 department, 7 department. When I say 7 department, what you did is you borrowed 3 bits from here and you say the length of the mask is /8 + 3, 11. And you started subnetting like this 10.0.0.0/11, 10.32.0.0/11. If you go back to your previous old classes of subnetting, you have done this. 10.64.0.0/11, 10.96.0.0/11. If you see, the length is not variable, it's the same length. Different departments, different subnets, but the length is not varying. The length is same. Now, what is the problem with the same length subnet mask? Variable length subnet mask and fixed length subnet mask. This is fixed length. For all departments, the length is fixed. But in the real world, we don't use fixed length subnet mask. We use variable length subnet mask, which I'm going to show you now in a few minutes. Now, what is the problem with this fixed length subnet mask? What is the problem with fixed length subnet mask? The problem is this. The size of the departments all should be same. The size. For example, if I have 300 people in production, are you going to have same 300 people in the sales? No. Are you going to have 300 people in HR? No. If all the department have got same number of IP requirements, same number of employees, if I have 300 employees in all departments, in each department, then I can go with the fixed length subnet mask. I'll do subnetting based on that info 300. But that's not the case in the real world. Every department has got different size. HR will be a small group. Sales will be a large group. The size is not the same. So the fixed length subnet mask will not suit our today's requirement. We need variable length subnet mask. Now, according to the requirement, when you do subnetting, your subnet mask won't be same. Your subnet mask won't be fixed length. It will be a variable length. For example, I'm taking 3 routers. 1, 2, 3. And the number of IP address needed for these two devices to communicate is just 2. If I have one IP address here and another IP address here, that's enough. So the subnet here should give me 2 IP addresses. I don't want more than that. Likewise, the subnet here also needs only 2 IP addresses because this is a point-to-point link. Point-to-point means what? You got 2 points. 2 points, each point 1 IP address, then 2 IP address. And this router is connected to a switch here, and also a switch here, and also a switch here, because you got 50 employees connected here, and you got 80 employees connected here, and you got just 10 employees connected here. You see, the length, the size of the departments are not the same. The number of IP address needed for these departments are not the same. If it is same, you can go with the subnetting that you did for this long. Here, the length is not the same because the number of IP address is not. The number of IP address needed is not the same. Here I just need 2 IP address. Here I need 2 IP address. Here I need 50 IP address. Here I need 80. Here I need 10. So we need to do subnetting accordingly. For example, if this is the network given to you, 10, 0, 0, 0, if this is the network given to you, now you need to start from the small one. How many IP addresses I need? 2 here. So let us do subnetting based on the small info. 2. For 2 IP address, how do you do subnetting? We have done that earlier. Number of hosts is how many? 2 hosts. 2 hosts needed. How do you do? 10.1, 2, 3, 4, 5, 6, 7, 8. Yeah. So what we do is we calculate 2, 1. This is enough for me. To get to IP address, when I add these two, I get 3. So this is enough for me. I'll keep this for host. I'll give the balance bits, all these bits starting from here for networking. When you do that, what is the length of the subnet mask? /30, isn't it? The total length is 32, but 2 you are not giving for network. 2 you have kept it for host. All the rest you have given for networking. 2 bits you have kept for yourself. 2 bits you have kept for yourself, host bits. And the remaining 30 bits you have given for submitting. All right. The length is now 30 for this requirement and for this one, because just 2 IP addresses needed. Now let us do the subnetting according to this. Ten dot 0.0.0/30. 10.0.0. Can someone say what number will come here? You forgotten this. No. How 60? Oh, why is this pen scribbling? Tell me. Repeat again. Louder, please. No. Why 60? Why 16? Listen. From here, you're giving for networking, isn't it? Now, what is the place value of this one? 4, isn't it? 1, 2, 4. So increment should be 4, no? You forgot this. I told you the other day. You need to increment by the number of the face value from where you're given for network. Okay. Now you see. No problem. Now you see. The first network, the first IP will be what? 10.0.0.1, isn't it? Tell me what will be the broadcast of this network? What is the broadcast of that first network with the mask 30? Okay, correct. So the last will be 10.0.0.2. If you see, first IP is 1, last IP is 2. No wastage of IP address. Achieved. So I'm giving here 10.0.0.1 and here 10.0.0.2. Fine. What about this one? I'll take the second subnet. Second subnet, first IP is 10.0.0.5. The broadcast is 10.0.0.7. The last is 10.0.0.6. So the first IP, last IP, let's assign 10.0.0.5, 10.0.0.6. You see, this is 10.0.0.0/30 network. This is 10.0.0.4/30 network. Yeah, we have used up to 7 in the 10 network. 1 to 7 is already been used. Now let's go to the next. Next smallest is this one, 10. All right, so I'm going to copy 10. How many hosts needed? 10 hosts. So we need 10 IP address. 1, 2, 4, 8. If I add all this, I'll get 15. isn't it? So is it sufficient? Yes. If I take only this much, I'll get only 7. Not sufficient. Not sufficient. Because I have 10 hosts, 10 IP needed. So I need these 4 bits for the host. I need these 4 bits for the host. Yeah. So what is next? Give the remaining for network from here, which will be 16. So your first network will be 10.0.0.0. What is the mask? Please focus here. The length of the mask is 32 minus 4, which is 28. I say earlier, you need only 2 IP. So the mask was 30. But now you need 10 IP. The mask is 28. Variable length subnet mask. So now here, this next network will be 10.0.0.16.28. And the next network will be 10.0.0.32/28. Increment of 16. Okay, it goes like that. 10.0.0.48/28. Yeah, goes like that. Now, what will be the first IP of this one? 10.0.0.1. What will be the broadcast of this one? 10.0.0.15. If you don't follow somewhere, please stop me. 10.0.0.14. Now, you see, you should not use this one. You know why? Some addresses from here is already been used. You see the diagram here? We have already used 1, 2, 5, 6. So better do not use this for the new department. Use this one. This one we have not used. So you are going to give for this 10 PC requirement, 10 IP requirement, 10.0.0.16/28 network. That's the network. That's the network. What is the first IP? 10.0.0.17. You see, first IP will not always start with 1. எப்பவுமே ஒன்ல தான் தொடங்கும் அப்படின்னா யோசிக்க கூடாது. பாருங்க, முதல் IP 17ல தொடங்குது. The very first IP is 17. In this subnet. Now, what is the broadcast? .31. What is the last one? .30. Now, this is the first one, and this is the last one. If you count and see, you will get somewhere around 15 IP address. You see, if you exclude this one, then 14 IP address. You get 14 IP address because this is network. So how many you need? You need only 10. So you got 4 extra. 10.0.0.15 is the first IP, and you have till 31, isn't it? The last is 30. The last is 30. Okay, so you have consumed up to this much so far. Up to 31 we have consumed. Earlier we consumed a few IP addresses from here. Now we have consumed all of this. Now let us go to the next biggest. After 10, the next biggest is 50. For 50, 1, 2, 4, 8, 16, 32, 64. So I need these many bits. If I take these many bits, I'll get 63. But if I take only this much, I get only 31. Not enough. I need 50 IP address. So I need this many bits for host. So you're going to give right from here for subnetting. Now what is the length now? 26. 32 minus 6. 32 minus 6 is 26. Why I say minus 6? Because I have used 6 bits for the host. I'm going to use 6 bits for the host. The rest are going to be given for network, which we call it as length of the mask. Now, what is the first network? As usual, 0/26. The second network, 10.0.0.64. You need to increment by 64. And then 10.0.0.128/26. 10.0.0. After 128 is what? 192. Goes like that. But this one, if you see, the broadcast is .30, the .63. Last is .62. First is .1. Some of the IP address we have consumed already. Up to 31 is consumed. So better don't touch this. Don't use this. Use this. 10.0.0.64. So that is the network of this department whose IP is 50. 64/26. You see the length is varying. Here /28, here /26, here /30. And what is the first IP here? 10.0.0.65. What is the broadcast here? 10.0.0.126. You see? The broadcast is .127 and last is 126. The first is 65. So up to 127 is already consumed. They're consumed. Now let's go with 80. Subnetting based on 80. Now for 80, I definitely need these many bits. So the length now is /25. How? Because I need 7 bits. Sorry, because I need 7 bits. 32 minus 7 is 25. Because the 7 bits are host. So right from here, we are giving for network. The place value here is 128. The first network is 10.0.0.0 as usual. I'm sorry, what am I doing? 25. And then 10.0.0.128. 128/25. Next, you need to keep adding 128. If you add 128 to this 128, you'll get 256. But we don't have 256. 2555 is the last. So it increments 1 here. 0. These things we have learned earlier. And next will be 10.0.1.128. Goes like that. But that's not needed for us. If you notice here, the last will be 127 will be the broadcast. 126 will be the last. .1 will be the first. And this is already consumed. You see, some of the address in this 1 to 126 up to 127 we have already consumed. So you don't use this. So we can use from here. So for this department, 10.0.0.126 is the network. I made a mistake. Yeah, 128. 128 is the mid. 128 is the net. And the first will be 10.0.0.129, and the broadcast will be 10.0.0.254. 5 will be the broadcast, 254 will be the last. So if you just calculate and see the number of IP addresses that you get, you'll get somewhere around 126 IP addresses. But how many you need? 80. It is okay. Few extra. Somewhere around 46 extra. Not too much you are wasting. When you do this variable and subnet mask, we don't waste. If I would have done fixed length subnet mask, what would you think my mask would have been? Slash 25 everywhere. Which means even for 2 IP address, I would have taken one of the subnet like this, which is not needed. There I need only 2 IP address. Here it gives somewhere around 126 IP address, not needed. Then I would have wasted many IP address, more than 100. Did you get this one? Variable and subnet mask. Did you understand variable and subnet mask? All right. All right. If you have not copied, no worries. You're going to have the video. I'm going to give you a homework. Are you ready for the homework? Similar to what I did, I'm going to give you the homework. Do it. Take a snapshot with your cell phone and send it via WhatsApp. In our next class, I'll open that file that you send me, and I'll check along with you whether it is correct or wrong. Yep. This is the homework. I got 1, 2, and and then I'd like to take some switch. And the number of computers connected here is 55. The number of computers connected here is 100. The number of PCs connected here is just 4. As usual, this is a point-to-point. And the network you're supposed to use is, that's all. This is the homework. Just 4. This one is just 4. Can you do this as a homework? All right. Take a screenshot if you want. In our next class, what we are going to do is we're going to go back to VTP, but we need to go VTP version 3 because there is something unique in VTP version 3. What is it? We learned a spanning tree protocol called MST. Now, when you configure MST on one switch, you need to go and configure on all other switches. If you have VTP version 3, even your MST configuration can be distributed. See, usually VTP we saw, it distributes VLAN. In version 1 and 2, it will only distribute VLAN. But in version 3, you will see more security as well as BTP version 3 can even distribute MST. So that's one pending, a high level of a kind of expert level of topic left in BTP. So in switching, we have learned switch fundamentals followed by VLANs, followed by port modes, followed by um, spanning tree versions, followed by VTP. So next topic in our switching will be VTP version 3. We'll talk about version 1, 2, and 3 differences, and we'll get into version 3 in depth. We'll stop here for the day.